there is a possibility that it rearranges itself to a more stable. What is the difference between the first substrate, the allylic radical, and the second is that you see the second one is more. What is the difference between the first and the second? Why is that rearranged to the second? Because it is more symmetrical. So because of the fact that it is more symmetrical, it can undergo or form two different types of substituted products. And we have seen this in the previous examples as well. So this is just a continuation of the things we have already done, but there is a separate topic of the free radical rearrangement, and that is very important. There are various other examples as well where we have seen that a primary radical may sometimes rearrange to a secondary or a tertiary radical. There are various examples where a primary radical rearranges itself to a secondary. Normally, we have seen this in carbocations. We have seen that a carbocation, the order of stability is tertiary, secondary, and primary. We have talked this in radical as well, where the order of stability is the tertiary radical is the most stable, followed by secondary, and then the least is primary, and followed by hydrogen. So when there is a possibility of a rearrangement, we say that the primary rearranges itself to a secondary and secondary rearranges itself to a tertiary, leading to the formation of the desired product. Now there is a possibility that the primary and the secondary radical rearrange by obviously reshuffling or shuffling the substituents or shuffling or the migration of a substituent. The correct word would be the migration of a substituent in such a way that it rearranges to a more stable intermediate. There are various examples as well. So let me draw the example of such a radical where a primary rearranges to a tertiary or a secondary radical. So let me draw this